We have AD is an angle bisector, so we'll use the angle bisector theorem to find these lengths on the opposite side. And we get that BD is 2 and CD is 3. We'll draw the perpendicular bisector of AD. This M is the midpoint of AD, and we have a right angle here. When I draw in these other two angle bisectors from B and C, then we can find points E and F at the intersection of these two lines. We want to find the area of triangle AEF. Since AM is the height of this triangle, we can use our standard formula for the area of a triangle. Let's find AM. Since M is the midpoint, that's half of AD. Let's use the law of cosines twice. First on triangle ABC. AC is 6, AB is 4, BC is 5. We'll solve for the cosine of B, and that's 1/8. We can use that angle at B again by applying the law of cosines to triangle ABD. We can plug in our lengths again, and 1/8 for the cosine of B. So AD is 3 root 2. M is the midpoint, so AM is 3 root 2 over 2. Now let's find the base of our triangle, EF. We'll restart with our simplified diagram. Since we have a bunch of congruent angles from these angle bisectors, let's label the congruent angles. We'll have alpha up here, beta here at angle B, and gamma here at C. Angle sum on the big triangle ABC gives us 2 alpha, 2 beta, and 2 gamma, add up to 180 degrees, or alpha plus beta plus gamma is equal to 90. Let's find some of these other angles. Looking at angle ADB, using the angle sum of triangle ABD, we have ADB plus 2 beta plus alpha adds up to 180 degrees. Solving for angle ADB, we'll substitute this 180 degrees using this expression, and angle ADB is alpha plus 2 gamma. Likewise, finding the angle sum of triangle ADC leads to angle ADC is equal to alpha plus 2 beta. We'll call the intersection of our 3 angle bisectors I. Let's find angle BID. Finding the angle sum of triangle BID, this angle is 180 minus beta minus alpha minus 2 gamma. Substituting again for 180, we get alpha plus beta. Angle CID, that's equal to alpha plus gamma. Let's simplify our triangle once again. I'll draw in EF and BC. This is the intersecting point I. It's perpendicular to EF at M. And we have D down here. And we'll fill in these angles. And we'll fill in the vertical angles in the triangle above. Since we have right triangles up top here, this angle at E is 90 minus alpha plus beta. And when we substitute and simplify, this is equal to gamma. Our angle at F is 90 minus alpha plus gamma. This ends up being beta. So we have congruent angles in the top and the bottom triangles. So triangle FIE is similar to triangle BIC. Since M is the midpoint of AD, we have IM plus ID. This is equal to 1/2 of AD, or 3 root 2 over 2. Let's find IM, the height of this triangle FIE on top, by using the angle bisector theorem on triangle ABD. We have AB over AI is equal to BD over DI. Filling in some of these distances, DI is AD minus AI. Multiplying by AI and dividing by 2, we get this. So AI over DI is equal to 2. So AI is 2/3 of AD, which was 3 root 2. So AI is 2 root 2. IM can be written as AD minus AM minus ID. Substituting, 3 root 2 for AD, AM was half of that, and DI is the square root of 2. This means IM is root 2 over 2. IM is the height of triangle FIE. So let's try to find the height of the similar triangle BIC so that we can find the ratio. Since I is the intersection of the angle bisectors, this distance from I to BC is the radius of the incircle. We can use the area of triangle ABC to find the radius of that incircle. First, let's find the semiperimeter of triangle ABC. That's 15 halves. Then we'll use Heron's formula. We'll find the square of the area by taking the semiperimeter and multiplying that by the semiperimeter minus all three sides. We have 3 squared, 5 squared, and 7 over 2 to the 4th. So the area of our triangle is 15 root 7 over 4. This is also equal to r times s. So we'll substitute and solve for r. That's the radius of our incircle, which is also the height of our triangle AIC here at the bottom. With these two similar triangles, we can find the distance that we're interested in, EF. The ratio of that to BC is equal to the ratio of the heights of our two triangles, IM and the incircle radius. Solving for EF and substituting, we get 5 for BC. IM is root 2 over 2, and dividing by the radius is the same as multiplying by 2 over root 7. And that's the base of our triangle, 5 root 2 over root 7. So we want to find the area of triangle AEF. That's 1/2 base times height, and we'll substitute. AM was 3 root 2 over 2. This is 15 root 7 over 14. They want us to express it as m root n over p and give us m plus n plus p. And the answer is 36. If you'd like me to solve any other AMC or AIME problems, please leave them in the comments.